the directions will say factor, and it's always going to say. Now you got to know that at some point you understand what I mean, but when I say factor, you got to factor completely. All right, so you have to factor completely. Factor completely. All right, the first thing you always do, and you can learn more steps as we go along, but the first thing you always do is look for a GCF. Step one is to always do a GCF. Look for a GCF. And there's always one. There's always a GCF. Either it's one or something else. Okay, so in number 40, you have this polynomial. Now remember, I'm calling these polynomials. So polynomials are going to be one or more terms, and the terms have one or more terms, and these terms are called monomials. Monomials. And what makes them monomials, what makes those terms monomials, is that the variables are being raised to a whole number. So something like 2x to the third power, that would be a monomial. 4x to the fifth y. Notice the exponents are whole numbers. Remember, your whole numbers, exponents. Okay, so your exponents are whole numbers. Your whole numbers are 0, 1, 2, 3, 4, and so on. Those are your whole numbers. So number 40 is a polynomial. Make sure you understand that that's a polynomial. In fact, everything you do in this chapter is going to be polynomials. So look at number 40. Make sure you understand that that's a polynomial. X to the ninth, y to the sixth, plus x cubed, y to the fifth, minus x to the fourth, y cubed, plus x cubed, y cubed. So make sure you understand that this polynomial, first of all, this polynomial has how many terms?
4.
4. And each term is a monomial. And monomials make up polynomials. And each one's a monomial because the exponents are what kind of numbers? Whole numbers. There aren't any fractions in the exponents. There aren't any negative exponents. So this expression that you see is a polynomial. This is not a polynomial right here. X to the fifth, y, minus 3x cubed, y, plus 1/5, x, minus 7x to the negative fourth, y cubed. This expression right here has how many terms? 4 again. What term here makes it not a polynomial?
7x negative 4.
The last one. What part of the last one makes this not a polynomial? The negative 4, because negative 4 is not a whole number. Your whole numbers are 0, 1, 2, 3, and so on. Okay, so when you factor polynomial, the first thing you want to do is look at all these 4 terms that you said, 4 terms, and see what the GCF is. So now the coefficients here are all what number? No, coefficient. Remember what number it is. 1 or negative 1, right? Okay. So in terms of coefficients, I don't have an issue with that. Now let's go to the variable. Is there an x in every term? Yes. So tell me at this point what you think the GCF will contain. X to what power? To the third. You always use the one with the smallest exponent. So x to the third. am I going to have a factor of y in the GCF?
Yes.
Why will I have a factor of y in GCF?
There's a Y.
Because there's a y, there's a factor of y in every term. How many will I need? 3 as well, right? So the GCF is x cubed, y cubed. GCF is not 1. If it's 1, we haven't done one like that yet, but if it's 1, it's possible, and you will have some that will have a GCF of 1, especially when we get further along. You'll have more of those. But here the GCF is x cubed, y cubed. When you find the GCF, how do you rewrite this using the GCF? Where do you put the GCF? It's in front, kind of like the distributive property, right? So you got to think distributive property. So it'll be something right here, some expression for this little box here. That's where the GCF goes. Because in your mind, you're thinking the distributive property, correct? So the GCF goes here out in front of the parentheses. So if my GCF is x cubed, y cubed, that goes in front. And then I'm going to have to fill in the parentheses based on the distributive property. Okay. X cubed times y cubed times what is this first term? You got to remember, when you multiply like basis from last semester and the semester before, actually last semester, what do you do with exponents? You add them. X cubed times what's x to the 9th? X to the 6th. So I know I'm going to need an x to the 6 here. Y cubed times what's y to the 6th? Y cubed. So do y'all agree that this times this gives me the first term? Okay. Plus, now you got to fill in that second term. X cubed times y cubed times what's x cubed y to the 5th? You think it's just x? Okay, now listen. Y'all are saying x, right? What's x cubed times x? X to the 4th. Is that what I had? No. So you wouldn't have an x there. What's the only thing you would have? Y what? Squared. Y squared. Okay? So always look at what you have. Think of the distributive property. X cubed, y cubed times y squared gives me x cubed, y to the 5th. You wouldn't put an x there. Because if you put just x, that's x to the 1st, right? What's x cubed times x? X to the 4th. That's not what that is. That's x cubed. Okay? So what you're saying is x cubed times 1 is what? X cubed. But we don't put the 1 there. You just leave it alone. Minus x cubed y cubed times what? X to the 4th y cubed. Minus x only. Not y. Because then that becomes y cubed times y is y to the 4th, and that's not what we had. Plus x cubed y cubed times what is itself? 1. You got to put something there. You got to have the term 1. So there's your answer. So a lot of things you got to remember from last semester in terms of multiplying like bases and the distributive property. The only new thing here is finding the GCF. Okay, so that's your answer. And notice in your mind you are checking as you went. You checked as you went. So if I have 4 terms here, I better have how many terms in here? 4. They better match up. Number 40. Okay, so let's look at 40. Let's do 40. Let's do 44. Okay, 44. All right, it's not that difficult. 44, you have 9y to the 6 minus 27y to the 4th plus 18y squared plus 6. Is this a polynomial? Yes. The first 3 terms, your variables are being raised to a whole number, and you have a constant. So a constant is a monomial. All right, what's your GCF? You better make sure that there's a y squared in every term. So is your GCF going to contain a y? No. Because you don't have a y here. Yeah, that's just 6. So now we're going to look at the coefficient of the constant. My coefficients are 9, 20, negative 27, 18, and 6. What's the GCF of those 4 numbers? 3. So what's your GCF? 3. GCF is 3. So then your answer is going to be 3 times whatever is in here. 3 times what's 9y to the 6? 3y to the 6 minus 3 times what's 27y to the 4th? 9y to the 4th plus 3 times what's 18y squared? And then plus what? 2. And there's your answer. All right. Let's see. 46. 2/5 y to the 7th minus 4/5 y to the 5th plus 3/5 y squared minus 2/5 y. All right. The fact that the coefficient of fractions is going to confuse some of you, but it's not that difficult. First of all, let's look at the variables. Is my GCF going to contain a factor of y?
Yes.
Yes, because there's y in every term. How many do I need? 1 factor. So I know I'm going to have a y in my GCF. Now let's look at the coefficients. The easy thing with this one is that all the coefficients have the same denominator. So if I cover all of these denominators, let me not do it that way. All right, so all of the denominators are the same, right?
Yes.
You want to take the fraction, your GCF is going to take the fraction, you want to take the one that has the smallest denominator. So you got to be a little bit careful though, because if you say, well, I'm going to take 2/5, the issue is that how do you deal with taking 2/5 out of here, correct? All right. So then what you want to do is this. If I cover up all these denominators and I look at 2, 4, 3, and 2, what is the GCF of 2, 4, 3, and 2? 1. So what will be my GCF then? 1/5 y. So basically, denominators are the same, right? So I know I'm going to have in my GCF, I'm going to have a fraction with 5 as a denominator. Then you cover those up, and then you just look at the coefficients without the denominator. 2, 4, 3, and 2. What's your GCF? 1. So you take out a 1/5. Okay? So remember, I think there might be one in my math lab like that. I don't know if there's one in the worksheet. Actually, there is. There's one in the worksheet like that. But that's what you do. You just find the GCF of the numerators. So this right here, if this 3, let's say, was a 8, what would be the GCF if that was an 8 right here? 2/5. 2/5, because the GCF of 2, 4, 8, and 2 is 2. Okay. All right, so then you're going to say 1/5 times y times what? Well, 1/5 times what's 2/5? Don't make it difficult. You had this long time ago. 1/5 times what's 2/5? 2. 2. So 1/5 y times what's 2/5 y to the 7th? 2y to the 6. Okay. 1/5 times what's 4/5? 4. So it'll be minus 4 what? Y to the 4th. Good. 1/5 times what's 3/5? 3. And then 1/5 y times what's 3/5 y squared? 3y, is that correct? And then minus what? 2. That's it. And it kind of makes sense that we're done now, because if you look at this polynomial that's left, what's the GCF of this right here?
last one be 2y?
No,
Oh,
because,
it's y. Okay, so
it's
we
y.
wrote it wrong then.
all right, so what's the GCF that's right here? 1.
One.
Okay. So if you do this correctly, the GCF that's in parentheses should always be 1. See this right here? What's your GCF now? 1. GCF 1. GCF 1. Okay. That's inside the parentheses. All right, so don't make the fraction too difficult. It's really not. You're just going to cover the denominators and you look for the GCF of the numerators. That's all you do. All right, now, the next one is going to help us when we get into something called factor by grouping. So that idea, factor by grouping. But before we do that, it's going to look like this. This is number 48. 48. Just like this. You have x times y squared plus 1 minus 3 times y squared plus 1. So when we do factor by grouping, at some point, and it's easy to do, you're not going to have any issues with it. When we do factor by grouping, at some point it's going to look like this. And now you're going to ask yourself, all right, I have kind of two things here. See, I'm kind of underlining two things. See these right here? Let me go ahead and do it this way. I have two products. Two products. I have x times this and negative 3 times this. See it? If you're doing this correctly in terms of factor by grouping, we'll talk about that a little bit in a little bit. But if you do this correctly, what's inside the parentheses should be the same. Are they the same? You can take out that factor. So what factor do they have in common? Y plus 1, so that's your GCF. So the GCF of these two things is what? Y squared plus 1. So just like they did before, you put the GCF in front, right? So you can say y squared plus 1. So the GCF is y squared plus 1. Okay? That's what they have in common. So you put that GCF in front, and then it's whatever's left. So how many things did I have on the line, though? 2. So you can have two terms in here. Y squared plus 1 times what is this? X only. Okay? When you take it out, you're kind of covering it up. What's left? X. Okay, cover this up now, and you're left with this. You're taking this y squared plus 1 out. What's going to be left? Minus 3, and there's your answer. That's it. Okay, so you wrote this as a product. So remember, factoring, you have something times something. That's a product. Factor means to write this polynomial as a product of polynomials. And it kind of makes sense because if you distribute, look, if you distribute, is this, what's the flow of my finger? Is this times this first thing here? Yes. Is this times the negative 3 the second thing? Yeah. All right. Just idea of the distributive property. All right, let's look at another one like this. Make sure you understand what to do. All right, this is number 50. Number 50. You have 8 times x plus 2 minus y times x plus 2. What's the GCF? X plus 2. GCF is x plus 2. So the GCF goes in front. And then how many terms are going to be inside this parentheses right here? 2. And what are they? 8 minus y. That's it. And always in your mind, think of distributive property. X plus 2 times 8 is this. X plus 2 times negative y is this. Okay? All right. One of the things in my math lab they're going to ask you to do is something like 54. So let me tell you what the directions are. The directions in 54 says this: factor a negative number or a GCF. Factor a negative number or GCF with a negative coefficient. So whenever we did the previous examples, just to kind of tell you what the difference is. So we did 44. What kind of GCF is this right here? Oh, yeah, but positive or negative though? Positive. When we did 46, this coefficient is what kind of number? Positive. In this problem, though, that you can look at, all they want you to do is, now, if they don't tell you anything about this direction, then you would just factor out a positive GCF. What's the GCF here if these were not the directions? You would say what? Not 3. No. GCF. What's a GCF? 7. GCF is 7. But in the directions, though, it says they want you to factor out a negative number for the GCF. So what's the GCF? Negative 7. GCF equals negative 7. And we said 3. In your mind, you were saying 7 times 3 is 21, but that's not the GCF. GCF is not 3. The GCF is 7. The directions, though, they want you to use what kind of GCF? Negative. So then, where does that negative 7 go? In front. How many terms will be inside the parentheses? 2. And you ask yourself, negative 7 times what is a negative 7y? Positive y. Negative 7 times what is a negative 21? Positive 3. Good. Positive 3. So there's your answer. You wrote as a product. Factoring, you're just writing things as a product. You're writing a polynomial as a product. So notice I went from this polynomial to a product. And it's a product, in this case, it's a product of GCF times this polynomial. And notice what's inside the parentheses. You always got to make sure that what's inside the parentheses, the GCF is now what inside the parentheses? 1. GCF is 1 here. Y'all see that? Okay, GCF is 1. The GCF of this, though, being negative is what, though? Negative what? 7. All right, what about 58? You have negative 5m to the 6 plus 10m to the 5th minus 5m cubed. Again, they would say, do you use the directions? Direction says factor out a negative, and on My Math Lab, they're going to ask you to do that. One of the problems will be, 1 or 2 will be to, the direction will say factor out a negative GCF. So don't say 5, you're going to say negative 5. All right, what about the variable? It will be m to the 3rd. So what's the GCF? Negative 5, m to the 3rd. And so that goes in front. All right. Negative 5m to the 3rd. Now using the idea of the distributive property, negative 5m to the 3rd times what is negative 5m to the 6th? M to the 3rd. Okay. Negative 5m to the 3rd times what is a positive 10m to the 5th? Very good. Negative 2. A negative times a negative is a positive. Negative 2m to the what? 2nd. Negative 2m to the 2nd. Negative 5m to the 3rd times what is a negative 5m to the 3rd? Positive 1 plus 1. So there's your answer. Okay? That's all you do. All right, any question at this point? So at this point, all we've done last week and today is factor out the GCF. Okay? All right, now notice that here we have how many terms? 4, right? Here we had 4 again. Here we had 3. Technically, there's really 4 terms here because this times this and then this times this. See it? And then this times this and this times this. So there are 4. So there are technically 4 terms there. Okay, now this is going to be number 60. I'm going to write number 60 out and I'll tell you what the direction says. Okay, 60. x cubed plus 4x squared plus 3x plus 12. All right. Now, if you look at all four terms, because the first thing you always want to do is see if there's a GCF other than one. There's always a GCF of a polynomial. Polynomial always has a GCF. What's the GCF here? 1. Okay? All right, GCF is 1. Then what you want to ask yourself is this, you're going to notice this will be in the steps at some point. How many terms do you see? 4. When you see 4 terms, you want to try and see if you could factor this by grouping. Factor by grouping. Now to help you in this section, the directions tell you factor by grouping. That's what the directions will say in this section. But at some point in the end, when you do all these sections, it won't say that anymore. It'll just say factor. You're going to have to know that if I have 4 terms, I want to try and see if I can factor by what? Grouping. And normally, most of the time, the way it works is that you want to try to group the first 2 and group the second 2. So it helps if you underline the first 2 terms, and it helps if you underline the second 2 terms. So if I cover up the first 2, the last 2, and you look at what you see, what's your GCF of what you see? No. No. X squared. Okay, you got to ask yourself, where'd you get a 1 from? Because those two terms, they both have x in it, right? So my GCF is going to contain an x. Now the coefficient will be 1. So it's the GCF of the first group, x squared. So I'm going to rewrite this like I've been doing before. You're going to say x squared times what? X plus 4. Just like this. Okay? You see that? All right. Now, I'm going to cover up that first group. And now I'm going to look at the second group. What's GCF of the second group? 3. So I'm going to factor out a plus 3. And then you're going to ask yourself, 3 times what is 3x plus 12? And does that kind of look like we did a while ago? All right. So now the next step is to look at the GCF of both of these things, which is now what? No. X plus 4. So your final answer then will be x plus 4 times what? X squared plus 3. There's your answer. So I'm boxing off what would go in the blank. So that's factor by grouping. So when you have 4 terms, you want to group the first 2, group the last 2, look to see what they have in common, the GCF. If you do this correctly, what's inside the parentheses should be what? The same. Once they're the same, you factor out what's inside the parentheses, that goes in front, and then it'll be x squared plus 3. All right, so that's kind of like number 44, whatever we did a while ago. All right, let's look at another one. Let's do 62. All right, 62, you have xy plus y plus 2x plus 2. Regardless of the first thing you always want to do is look to see what the GCF of this polynomial is. Because if there is a GCF for the polynomial, you want to take that out first. What is the GCF of the polynomial? It's just 1. Okay. So then what do you want to ask yourself next? See if you can do this by what? by grouping, because there are how many terms? 4. Chances are you're going to be able to group the first two and group the last two. So go ahead and group the first two, group the last two.
So how do you know when you're supposed to factor by grouping? Only when it gives you instructions to?
No, there are how many terms?
I know, but why didn't we factor by grouping on any of the other ones that we did then?
That's a good question. Because in this section, the main part of the section was to find the GCF. So in the other problem that we had 4 terms in, like this one right here, this right here, if you had, let me do this one. If you had done this by factor by grouping, so what could I, the 4 terms, right, y'all? Okay, so I'm going to not put this, well, okay. So if I had done this by factor by grouping, what's the GCF of these two?
3.
Nope. 9y to the 4th. 9y to the 4th times what? 3, oops, y to the 2nd minus 3. Okay? Okay. What's the GCF of this? 6. So plus 6 times what? Are those the same? No, factor by grouping doesn't work here. Because these things inside here are what? Not the same. So as you go through the course, when you have 4 terms, you're going to want to try factor by grouping. Now, granted, these have 4 terms. 4 terms. If you try factor by grouping, it doesn't factor by grouping. So the only thing you can do is to do what? GCF only. That's all you can do. Okay? All right. So here in this one, always do with the GCF first. GCF here is what? 1. Okay? Once you find the GCF, since it's 1, you're not going to say 1 times in parentheses, since that's just a 1. Now you're going to do factor by grouping because there are how many terms? 4. So you want to see if you can factor by grouping. If this cannot be factored by grouping, we haven't talked about this, but then you're going to use a word cannot be factored, which is prime. You would use the word prime instead. Maybe remember the word prime before. Prime. All right, so let's see if it is factored by grouping. Is this one right here factorable by grouping? No. We tried. It doesn't work. What's inside the parentheses were not the same. Okay? So let's see if this is factorable by grouping. First group, what do they have in common? Y times what? X plus 1. Second group, what's the GCF? 2. Plus 2 times what? Are those parentheses the same? Yes. So is this polynomial factored by grouping? Yes. What's the answer? Y plus 2. There's your answer. X plus 1 times y plus 2. And remember, one of the things you turned in today, if you FOIL this, remember this right here? You have to turn in that today. If you FOIL it, let's see if we get this thing back. First times first, what do you get? XY, yes, XY. The outer, what do you get? 2x. The inner, what do you get? Y. And the last, what do you get? 2. Is that what this was? Yeah. Okay. That's what that was. All right, so factor by grouping. So the one we did earlier, all we could have done here, remember the first thing you always got to ask yourself when you have a polynomial is, what is the GCF? So here the GCF is 3. If I try, and I notice, well, there are still 4 terms here, so is this factored by grouping? You're going to notice it's not. So you're done. This is your answer. Okay? All right, let's do this one. Suppose we had All right, suppose we had let's say we had this. I'll make this write this example. $16 W squared plus 14 WV plus 16 W plus 14 V. Was the first thing, when you factor, was the first thing you always need to look for? GCF. Is the GCF 1 here? No. What's the GCF? 2. Always do the GCF first. So I can factor out a 2, correct? Okay. So 2 times what? 8W squared. Come on, y'all. 7WV plus 8W plus 7V. Okay, that's where I'm at. But remember, it's always factored completely. So just because you took out a GCF, it can still be factorable, possibly. So look at what's inside the parentheses. How many terms? 4. If there are 4 terms, I'm going to write it over right here. I'm going to write those 4 terms. 8W squared plus 7WV plus 8W plus 7V. You want to ask yourself, what question? Is this, right here, factor by grouping? All right, let's see. How do you determine it's factor by grouping? What do you group? First 2, last 2. What can I take out the first group? W. W times what? 8W plus what? I'm sorry. Yeah, 8W plus what? 7V. What is the GCF of that second group? Don't make it difficult. What's 1? Good. So you can say plus 1 times what? 8W plus 7V. Look at how it looks. See that 1 I put in front? You see it? Now, is what's inside the parentheses the same? So I'm going to ask you this. Is this right here, what was inside the parentheses? I'm covering up the GCF of the 2. Is this right here factorable by grouping?
Yes.
Yes. So what do I write this as now? Plus 1, and that goes here. So the final answer has how many factors in it? 3. 2, and then what? 8W plus 7V times what? W plus 1. So there's your answer. So you're going to, as you go through the process, the first thing you're always going to ask yourself, what's a GCF? If something other than 1, you factor it out. The GCF is part of your answer. Then whatever is left, you ask yourself inside the parentheses, can I factor that further? How many terms do you see? 4. What do you want to try? Grouping. Okay? So here's the work for the grouping right here. All right, let's look at 68. 68. All right, 68, you have 6x minus 42 plus xy minus 7y. Okay. What's the GCF of the polynomial? 1. Whereas in the previous example, the GCF was 2. And you see what it looked like the answer? Your answer still contained the GCF. But since it's 1, don't say 1 times the parentheses because it's this polynomial still. So how many terms do you see, though? 4. What do you want to try? Grouping. So let's group the first 2, group the last 2, and see if this helps. What can I factor out the first group? 6. 6 times what? X minus 7, right? 6 times x is 6x. 6 times a negative 7 is a negative 42, distributed property. What can I factor out the second group? What's the GCF here? Y. So plus y times what? X minus 7. Are the parentheses the same? So what's the answer? X minus 7 times what? 6 plus y. There's your answer. Okay? If you followed it out, you would get the original problem back. If you follow this out. All right? Okay, let's look at this one. This is going to be number 70. Number 70. All right, now, look at number 70 and tell me what you think the difference is from 70 and the previous 4. Okay, here's 70. 2x cubed minus x squared minus 10x plus 5. So 2x cubed minus x squared minus 10x plus 5. So the idea is the same, though. GCF was the GCF. 1. Okay. How many terms do you see? 4. So you want to try what? Grouping. Normally, what's going to work, not always the case, but for the most part, almost all the time, the way it's going to be set up in here, the way it's going to be set up in here is that you'll be able to group which ones? First and the last, 2. So far, everything we're doing looks the same as what we've done a while ago, right? So first group, what's the GCF? X squared times what? What is it? Not 2 minus x, 2 what? 2x minus 1. Where'd you get 2 minus x from? Look at it again. You see what you forgot? Okay. Now, when we did the others, and look at the others, when the second group, what was the GCF here that I'm pointing to in the second group? 2. 2, right? And so when I wrote it as plus 2. What was the GCF here? The second, I'm sorry. What was your GCF here? 1. When I wrote it as what? Plus 1. What's your GCF here? Y. When I wrote it as what? Plus y. So if you look at each one of those, when I wrote that second set of parentheses, this operation came from this sign here. This operation came from this sign. This operation came from this sign, that third sign. This operation came from here. So, when I look at this group, what will I factor out? A negative, what? 5. So you say minus 5. This operation comes from this sign right here. Okay? And we did something like this a while ago. Negative 5 times what is negative 10x? 2x. Negative 5 times what is a positive 5? And notice with the parentheses, what do you notice about them? They're the same. So always remember, when fact about grouping, that second group, you can take out the factor, the GCF, with this sign right here. If this was a plus 10x, you would have done a plus 5. If it's negative 10x, you can do a negative 5. So what's the answer? Yeah, and that's it. There's your answer. All right, let's look at 74. 74. You have 5xy minus 15x minus 6y plus 18. All right. Always look at the GCF. What's the GCF of this polynomial? What? How many terms do you see? So what do you want to try? Grouping. What are you going to group? First two, last two. First two, what's the GCF of the first two? Not just x, 5x. 5x times what? Y? Minus 3, because 5x times y is 5xy. 5x times a negative 3 is negative 15x. Second group, what are you going to take out? What's the GCF of the second group? Negative 6 times what? Y minus 3, because a negative 6 times a negative 3 is a what? And what are you just about inside the parentheses? So what's the answer? Times 5x minus 6. There's your answer. And if you were to follow it out, which on a test you don't have time to, but if you were to follow this thing out, you would get the original back. Okay? Remember, factoring completely means this, that if you look at these two binomials, what's your GCF of inside the parentheses right here? 1. What's your GCF here? 1. So if you factor completely, the GCF of what's inside this parentheses better be 1. Okay. It is possible in my math lab to have something like this. I don't have it on a worksheet, on this particular worksheet though. But look at 72. You have this 7x minus 21 plus x cubed minus 2x squared. 7x minus 21 plus x cubed minus 2x squared. All right, that's going to be a little bit more challenging because remember what I said. On your test and on your final, if they do have a polynomial that you would have to do factor by grouping, you will be able to group the first two and group the last two. But remember, I always said that almost in all cases, you'll be able to group the first two and group the last two, right? Yes. Okay. One of your worksheets we're going to do next time, though, when you group the first two, group the last two, it won't work. But if you rearrange the terms, it is possible for it to work, for it to be factored by grouping. But at this point, it was always the first two, the last two. Now let's look at 72. If I group the first two and group the last two, what's the GCF of the first two? 7. Times what? Times 3. What's the GCF of the second group? Plus x what? X squared, right? Times what? X minus 2. Are these parentheses the same? No. So that did not work. If I were to rearrange the groupings, so in other words, instead of putting 7x minus 2 and 1, put 7x plus x cubed. Just watch. X cubed, and then say minus 21 minus 2x squared. See if that will work. See what I did? I just rearranged. I just put them in different order. Okay. Do the same thing. What's the GCF of this now?
1.
No, right here.
7.
Right here.
No,
X only. What's x times what? 7 plus x squared. What's the GCF here? Be careful.
1.
What kind of 1 though?
Negative 1.
Take out the negative. Times what?
21.
21 plus
2x.
2x squared. Are those the same?
No.
No. In fact, if you keep rearranging it, nothing works. Okay? Nothing will work. Trust me. I don't want to waste the time doing this. Nothing will work. So then you would say, and we hadn't talked about the word prime yet, so then you would say, and then they would say, in the direction says this, if it's not possible, write not factorable by grouping. So you would say what? Not factorable by grouping. Okay? Not factorable by grouping. Now, we're not going to use the word prime on this because it is possible in college algebra. It is possible, and you have in this course when you factor by grouping. When you factor by grouping, we group the first two, group the last two, or group two at a time. It is possible in college algebra, though, that when you have 4 terms, you could group the first 3 and leave the last one alone, and then you would have some factoring strategies. That's in college algebra. That's not in here. So at this point, you just say not factorable by grouping. Okay? So I don't know if there's any on my math lab that's like that. I'm not going to have one in the test like this or a worksheet, but at some point, though, when we do the trinomials, there are going to be some that you're going to have that's going to be prime. And we're going to talk about the word prime when we get to it. All right. Now, that was this section. Any questions at this point? That's all this was. So let me show you some worksheets that goes with this. So this is, I gave you part C last time, right? If you went here, you got to download it from Canvas. All right, so here is part D. Let me show you what it looks like. And all I want you to do in part D is to factor out the GCF. That's it. Now, mistake people make, and every semester they do this, even though I say what I'm about to say. The answer is not the GCF. So you don't put in the blank 6, right? What do you put in this blank, in the first blank? 6 times x minus 2. I didn't say like the worksheet C that said, what is the GCF? I said what? Factor out the GCF. So you guys say GCF times whatever's left, okay? So those are easy right here. Here, we talked about this, we talked about this, we talked about this. We talked about this fraction, what to do there. And then this will be factor by what? Grouping, okay? Factor by grouping. All right, now, oops, I'm sorry, excuse me. Do the GCF first. What's the GCF? 3 only, right? Okay, turns out, guys, just like we did a while ago, it turns out that if you factor out the 3, those 4 terms that are inside cannot be factored further. So all I want you to do here is just to do what? Factor out what number? 3. Because those 4 terms, you won't be able to factor by grouping. It doesn't work. But it's still factorable because you factor out a what?
3.
A 3. Okay. So all you do here is factor out the what? GCF. What's the GCF here? 3. So 3 times whatever's left. Okay? The next worksheet, though, is this. That's D. Okay, here's E. This is the one that says this is the one that's this is the one that says factor by what? Grouping. All right. Now, first of all, you're always going to look for what first, though? GCF. So GCF in all these is 1, I think, so far. Let's see. That's 1. That's 1. That's, oh, no, that's 1 as well. Yeah. Oh, here's 1 that's not 1. What's the GCF? Can you see it?
7.
Nope, 7 does not go into 16. What's the GCF of 70, 40, 28, and 16? 4 does not go into 70. 2. And then into what power? 2 what? What's GCF, guys? 2n. Now, this time, though what's inside the parentheses, you will be able to do what? Factor by grouping. Okay? We did one a while ago. Remember that example I did? I took out it was this one right here. It's kind of like this. I took out a what first? A 2. And then we went off to the side and we did this by grouping, and then that was the answer here. So that number 8 is going to look like that example. And then, no, because, 3, yes, 3, excuse me, yep, 3, very good, thank you. 3 is a GCF, and so 7 and 8, you're going to do like this example right here, okay? You all agree? All right, 7 and 8 will look just like this example. You can take out the GCF first, and then you could factor by grouping that parentheses. The other 6, though, will be strictly what? Grouping. Okay? Now, knows the directions. Direction says, show the work as presented in class. So use these notes to show to make sure you see what I want. Just don't go from this to the answer and put the answer in the blank. Do what we did. On the line, the first 2, last 2, and then basically all I want is this middle step right here. No, this was the work, right?
Yeah.
This right here was the work right here. That's the work. This is the work. This is the work. Along with this, though. See this and this? All right. Okay? All right, so that's E. Now there's an F, which I can't give you yet because this F, this right here, that's the one where it says, show the work. Okay, make sure you factor out the GCF whenever possible. You must show work as presented in class to receive credit. Factor by grouping. How's that? Oh, what's going to happen here is that you're going to have to rearrange the terms. Just watch. Let me just double check that this is the one I can't remember yet. What's the GCF of the first 2?
3.
Oh, well, first of all, what's the GCF of the, is there a GCF of the whole thing?
No.
Nope, you're right. All right, so 3 what? X? What do you get?
4x squared.
5? Okay. 5y, is that correct?
Yeah. Yes.
What about the second group? Minus 2y, is that correct? Times what? Negative 2y times what? 8x squared y. 4x squared?
5. No, yeah, 5 plus 5. Y.
So I guess you could do that when you have enough information to do this, huh? Okay. I just got to make sure that there's nothing that you can rearrange because I thought there was something in here that could. So I don't want to give that just yet. So the answer would be, what would the answer be?
3x.
Well, do the parentheses first. 4x squared plus 5y times what?
3x minus 2.
Yeah, that would be the answer. So it's kind of like part E. Except I want to give you this one because I think there might be 1 or 2 in which you're going to have to rearrange the terms. And I just got to go back and do them again and make sure. Okay? So I'm not going to give you that one just yet because I think there are some like that. All right. But we're done with this section. On Canvas, on My Maths Lab, I don't think there are any that you have to rearrange. So I'm going to assign section 13.1 tomorrow. So let me give you those 2 worksheets. What time is it?
8:34.
8:36? All right, let me give you those 2 worksheets.